Peter, I'm going to bring you up. Sir.
Hey.
We got this cool graphic that Rihanna's made. Peter, you have, again, another... Folks, this is not a weird thing that people come from other backgrounds into cyber. But, Peter, you have an electrician background. Is that correct?
Yes, that's what I've been doing the past 10 years.
Nice.
Yes. Yeah.
And you've got some awesome stuff for us. We have been doing slides a little differently.
Okay.
If you want to attempt, we can have you share your slides, share your screen,
Uh-oh.
and then you can click your own slides. If you're not set up for that, I can go through the slides that you've already turned in, but apparently there's not the function for you to hit next on those slides. So
okay.
You just have to say, like, next slide, and I got you.
Sure, we can do that.
A pretty decent job of that all day.
Yeah. Are we already live?
Oh, we have been live, yes.
Okay,
Unfortunately,
cool.
I'm the awkward kind of person that just does this for all of the folks out there streaming to listen to as well.
That sounds good to me. Thank you, everybody in the chat.
With that, Peter, I've got some prepared words. Correct me if I on your last name, Peter Gaudiomonte.
Gaudiomonte, yes.
Gaudiomonte.
Yes.
Is a network security analyst who came into cyber from an unusual direction, the trades, as a working electrician, and now writes and builds at the intersection of hands-on hardware and network defense. He's a contributor to CyberSpeak Labs and has covered threat hunting, network forensics, and practical Raspberry Pi security projects. Peter, it is great to have you, and
Thank you.
I'm gonna let you begin early if you're ready for that.
Yeah, that works for me.
Excellent. And I'm gonna bring up your slides, and I'm gonna get it out of the way.
Alrighty,
Peter.
Can we move them over like we did for Pat's, right onto the side of the screen, perhaps? Oh, maybe not. That works too. Okay. Everybody hear me okay? I had some difficulties with my microphone. So, like he was saying, I continue. I am still an electrician at this point, unfortunately, and I've been trying to migrate into IT for the past 2 to 3 years. Back in August 2022, I had to have a kidney transplant. And I realized at that time that I'm probably going to have to switch careers at some point, and I thinking about IT is something that I could do anywhere. And God forbid, if I ever do have to get back on dialysis, I can work from home. I can work from the chair. And that has been my entire focus the past 3 years, was just gaining experience, hands-on experience with all the different tools, Linux, networking, as much stuff as I can get my hands on. And I like to reuse a lot of old equipment and see if I could, breathe new life into it, reduce and reuse. And see, let's start getting into Wireshark. So I know I'm not going to make the big assumption, but a lot of people, including myself, was only a intermittent user of Wireshark, and I really only used it in CTFs or cyber competitions and whatnot. And it wasn't one of those advanced tools that I really thought about much. And as more as I got into it, I realized that Wireshark can teach me every single thing I want to know about networking, protocols, and it's cool because I can look at the logs, I can look at the behavior, what's happening on my system, but you cannot get the same granularity with logs as you can with seeing it right on the wire, right in the packet. So I have about 30 to 40 slides. I'm going to try to keep it quick, on point, but I know I like to get in tangents sometimes, so just bear with me, guys. And this is only my second time speaking. Again, bear with me. So I'm going to try to go through who am I, the whole Wireshark interface and fundamentals. I'm going to try to skip a lot of the really, really beginner stuff that most of us, or that I know when I first started using Wireshark was kind of blatant. I'm going to try to stick with the things you really get to see that much, or maybe some advanced topics. Okay. So the Wireshark interface, fundamentals, key protocols, normal behavior. And then we're going to go to display filters, buttons, profiles. We're going to try to get into the TCP handshake, three-way handshake. Out of band traffic, excuse me. Normal versus malicious. And then we're going to get into TLS fingerprinting with Job4 Plus. That was something I have actually spent the last year playing with. Last year, I went to Shark Fest down in Richmond, Virginia, and John Althouse was out there, and he did a presentation on Job4 Plus fingerprinting, and I thought it was one of the coolest things I'd ever seen, that you can glean so much information from encrypted packets, encrypted traffic, and I've been fascinated. I've set it up in my home lab. I've been using a Wireshark, Zeek, Archemy, just all these different tools to pick apart the packets and really see how these fingerprints work. And then we're going to look at an Nmap scan in the Wireshark sense and how Zeek kind of looks at it. And I want to say that I want to give credit to a few people here that have been pretty instrumental in my path. Marcel Lee, she does a great a weekly newsletter. Betty Dubois, Chris Greer, Ross Bergertis, and Eric Conrad. They've all had a pretty direct, important impact on my work. So we can get on to the next slide. Thank you. So I guess I would say, like Katie said it earlier, I'm a wannabe security researcher, whatnot, but I have been doing it for 3 years. I've been an intern with the Carolina Cyber Center for about 2.5 years, and I've done a lot of really interesting work with them, understanding how markets work and corporate things. I'm a father to 2 beautiful boys, 14-year-old and 8-year-old. That's why I'm doing all this stuff. That's why I'm in school, or I was in school, just trying to expand my knowledge. Like I said, I was on dialysis for 6 years. I had a kidney transplant. I also had to have heart surgery. That was interesting. And so now I still do electrical work, unfortunately, but I'm working my way towards finding a better career. So I do electrical work during the day, and I do my internship at night. Just at the moment, past 3 years, just been trying to gain experience, document my journey, and really help others. So I'm a tinkerer. I love Raspberry Pis, just open source hardware, open source software, and whatnot. I would say I'm a wannabe Python programmer, Bash, whatnot. I really believe in the right to repair and right to own. There's a lot of stuff we've been seeing lately about John Deere, the McDonald's ice cream machines, and some other the games, the video games. What PlayStation Store just done, revoking all those purchases we made. I spoke at B-Sides last year. Thank you to Marcel Lee for inviting me. I met Raina at Secure World about 2 years ago, and she was speaking about threat detection as well. Not basically about Wireshark, but how you encounter it in your day-to-day. And I love packets and protocols. Like there's so much information that you can just learn. Like even at the beginner level, you could just break open Wireshark and it tells you, like the TCP/IP model, it's right there in front of you. It's so cool. Last Shark Fest I went to, we had Vint Cerf there. He was like the inventor of TCP, one of the grandfathers of the internet, and he spent a good 30 to 40 minutes talking about space and the challenges and the new type of infrastructure and protocols we're going to need to communicate those huge distances. And with our current infrastructure and TCP, IP models, that latency would just be too great in in the grand scheme of things. So if you get a chance, look him up, and he has a lot of interesting thing to say. Uh, go to the next one. Thank you, thank you. And a little more about me. Like I said, I love to document my journey. I love to share what I've learned. It just it's not necessarily helps. I mean, it does help other people, but it really helps me to drill it down when I document the entire process. And I just, I love this stuff. I really do. And if I can share it, my knowledge and experience, I'm going to. So if you get a chance, check out my LinkedIn blogs. I got a Medium blog. It's fun. And I think you'll be able to see that through my work. Oh, and one of my favorite projects I built was I had a break-in last August 1st. And so I set up a Raspberry Pi running Kismet, and I was tracking the Wi-Fi probe. So it kind of gave me a notification if anybody kind of steered close to my house, and I live out in the country. So there's 10 acres of woods. So if you're within radio distance of me, you probably shouldn't be out there. And it was just really cool to see how all our devices try to, like, as long as you have Wi-Fi on, it's always beaconing out there trying to find home, or the less strongest network you've been at. So it was really cool to see these devices that I didn't know, and they were just reaching out to their home network. And at the same time, I've been documenting our entire city's, I guess, wireless infrastructure with Wiggle, that big database. And some of those probes, you can see it has exactly those SSIDs that it was trying to search for. And on a few occasions, I could see exactly where this person lives based on their SSID and based on their device with Wi-Fi on, not connected, but beaconing out. Say, hey, where's home? Where is my last SSID? And I thought that was, I haven't made a full blog about it yet, but at some point I will. I look forward to doing that. But it's just a cool little project, to see who is around my house. That's all. We can go to the next one. So Wireshark has a real cool, interesting history with Gerald Combs. He used to be called Ethereal, and he built it because he needed to figure out what was on the wire. He was working at an ISP at that time, and I think it's one of those amazing things in history that he just gave it out to the public. Really, it's open source, it's free. Now at this time, the Wireshark Foundation, takes care of it and runs it, and they are donation based as well. They have different memberships you can join on YouTube, which will allow you to see the past year's Shark Fest videos. I know there's some out there online already on YouTube without having to join a membership. A lot of those are Chris's videos. As you all probably know, he's very knowledgeable in Wireshark. But again, they live off donations as well. And last year, they actually put out the Wireshark certification, the Wireshark Certified Analyst. And I am still working on that one. It's kind of hard to keep doing everything, and with a full-time job during the day, I get home and I'm exhausted, and it's hard to stay focused and, stay on track. But that's another way they support themselves with new certification. It's real. It's intense, actually. You can go on wireshark.org and you can get what are they called again? The objectives, and it'll take you through exactly. And what I noticed with, like, I did this for the CCNA, Security Plus, and Net Plus. What I did was, even if I wasn't planning to take those certifications, I took the objectives and I broke it down into each section. I said, all right, I'm going to study this section here, and then this and this and this. And it's like going to school for free. I mean, there's so much free content out here that it is really a great way to study. I mean, just to get, and it's Wireshark. It's free. Just download it and boom, you're learning. They created a Wireshark course. Chris has one, real hands-on. I think there's about 55 different packet captures available, and his course it's a reasonable price. And the WCA certification is, industry standard price. And another way to help the Wireshark Foundation is to go to SharkFest. I'm actually leaving Monday morning at 4 a.m. to go to Nashville, Tennessee for Monday the 20th to Thursday. So I'm really looking forward to that. It'll be my second year. And one of my friends named Jen, she actually won the women's scholarship, where you write an essay and send it into the Wireshark Foundation. And if they like it, they'll send you to SharkFest for free. It's last year, this is where I learned about Job 4 Plus and all the great stuff they're doing at Fox.io and Salesforce. So I think we can move on to the next one. All right. So this is our basic setup. I'm pretty sure all you know about it. You got 3 different sections, all your packets coming in, our packet details, and bytes in the third section. But a lot of people don't know about the next one. As you can see here on your panel 3, there's different ways. It's something called packet diagram. And if you can go to the next slide, I can show you exactly what that looks like. Oh, well, first we're going to talk about bits and bytes. Something I struggled with a lot. I mean, I still do at times, and you don't really think about it, and you really got to sit down and think about, okay, bits and bytes. But for anyone new here, I was going to go through a simple walkthrough. All right. 1 binary digit is a bit, a nibble is 4 bits, and 1 byte is 8 bits. And if you want to go from bits to bytes, you divide by 8. If you want to go to bytes to bits, you multiply by 8. And it's not always, it wasn't always 8 bits to a byte. Early computing used 6-bit, 7-bit, 9-bit bytes, depending on the architecture. The 8-bit byte one, because it cleanly represents 2 hexadecimal digits, as you can see here. And it maps perfectly to ASCII. 7 bits of character data and 1 parity bit. IBM standarded it with the System 360 in 1964, and the industry followed. As you can see, your ISP, they sell it to you based on megabits per second, because that number looks bigger than megabytes. And so 1 gigabit per second actually equals 125 megabytes per second of actual transfer rate. And there's probably something in there that I've gotten wrong or misconstrued, but that's a quick little overview of that. We can move on to the next one. Thank you. And here's what I was saying with the packet diagram view. Normally we see the packet bytes. So you see the hexadecimal in that third column or third pane. And you see all that, usually see what all that uh, jumbled bytes. And sometimes if you're working with unencrypted data, you can see usernames, you can see passwords, you can see HTTP headers, all that stuff. But here, real quick, um, here it gives us a unique view of how the packet's encapsulated with Ethernet headers, then your IP, then your TCP, and anything after that follows. So seeing it like this for me as I was learning, I could see exactly where in the packet it was, you know, and it helped me to really visualize what was really going on, because you see that theory and it's like, okay, I'm reading this over and over again. And then once you see it on the wire, it helps a lot to it helps a lot. And an interesting thing too with sequence numbers, you know how there's relative sequence numbers and raw sequence numbers. They use raw sequence numbers because they're such large numbers, and it helps to prevent packet injection, in that connection. So then for us, it's easy to visualize it in app. It's as relative sequence numbers, so it starts at 0, and then 0, and then 1, and 1 goes forth. So what's cool though is for these really long connections, you can actually see sequence numbers wrap around. It's usually when you're transferring large amounts of data for a long time. So, but we can move on to the next one. All right. So, like I said in the beginning, we're going to go over the interface and the layout. We talk about fields, profiles, and buttons. So everything that is in the packet, Wireshark it's a field, it's a value, and there's a lot of things you can do with those. You can add coloring rules, you can create a specific filter, you can create a specific column, you can even create buttons. Say we have it here, IP.source. All right, blatantly we know that's our source IP. But you can also put IP.adder equals 10.12. And regardless if it's source or destination IP, it'll show it. So you don't have to specify that. And here, it's a little hard to see on here with the stream index 35 in the photo all the way to the right. That's a value Wireshark has provided. So think of that as like metadata. And that really comes in handy over time, as we'll start seeing some more. And you don't even have to type in your filters. You drag and drop. It's really all you have to do. And if you don't know what the specific name of that field is, it will always be in the bottom left-hand corner of the Wireshark screen, right at the bottom. You can see in that third picture, the source address is IP.source, and it tells you exactly how many bytes that field is. Okay. And I'm sure a lot of you know how to make and or to build different logic. So it's a fun way to play around with it. And you could actually take that value on the top and turn it into a button. But let's move on to coloring rules and columns, please. Cool. All right. So coloring rules are specific to, they're profile specific. So if you have a certain profile that's your favorite, again, a profile is just to set up a configuration of Wireshark that you've already set up, and the columns are how you want it, the field values are how you want it, and you can add in their colors. So it's so you don't have to look at the packet. You already know what's there. So even without seeing what are the values in my packets, I know those green values are SYN packets. They're the beginning of the three-way handshake, the SYN and SYN-ACK. And then at the bottom, I can tell those are fin. When the connection closes down gracefully, each side sends a fin packet. And again, the coloring rules are profile specific. So if you're working TCP one day or VoIP or wireless, your coloring rules will be for that profile. We can move on to the next one. Time. Time is very important in Wireshark. And my favorite is the delta time. So that is its own column and its own value. And it's really just the time interval between the last packet, or actually between the last TCP packet, or TCP segment, excuse me. At TCP analysis.ack RTT, it tells you what is the return trip time. And again, like here, you can set up your columns however you want. And that is a way to build your profiles. And what's cool about delta time is you can click it, you can sort it to the highest, which would mean that your packets are very slow, or you can swap it around and say, okay, I have no issues here. They're going at perfect time. Here you can see 59 seconds. So one of those connections really, it took some time. But that's so we can see slowness. That's all. We can go to the next one. So here we're going to get a little more granular about time. So like I did for the first one, time, the delta time is the raw and unfiltered time since the previous packet in the entire capture. And you can go a little further on that one. What's the delta time displayed? That's the time since the previous packet and you're currently visible in that filter view. So as your filters change, that displayed time will change as well. Next one is TCP time delta. So this is the time since the previous packet in the same TCP stream. So if you're in stream 3, it's not going to show you any time related to stream 1. It's just that's per TCP conversation. And the last one is tcp.analysis.ack RTT, like I explained that before. It is the corresponding ACK with the true round trip time for that segment. Delta time is calculated at the analysis layer. It's not a field transmitted in the packet. It's like those brackets, those Wireshark time, those Wireshark values, that the metadata. So accuracy is really important here, and you have to make sure you have the same, or all your time is set up correctly. You know, it says here your timestamp resolution and interface clock drift. So, but we could move on to the next one. Thank you. So here, why should we use profiles? Like I was saying earlier, if say you're working on HTTP one day and you get a packet in from a friend that says, hey, can you look at my wireless traffic, please? And boom, as soon as you open up that packet capture in Wireshark, you can see the SSID, the BSSID, which is the MAC address. You can see the different probes, and it's kind of hard to see, but if you look at the WLAN sec profile at the bottom, you could, some of those buttons are actually menus. So when you click on, say, beacons, you can see probe response, or probe requests, probe response, and whatnot. It gets really, really granular. And you use it to just instantly query the PCAP. That's what our buttons are for. You don't have to type anything in. All your filters are already set up and ready to go. Okay. Second, that filters are reproducible and shareable. Like setups. So you can send it to your friend, or you can even download someone else's very well built profile, like I did with WLANsec. So, and what's cool is I can go through it button by button, filter by filter, column by column, and just dissect it, reverse engineer what that person set it up for. In the next PCAP, you will see, move on. In the next PCAP, you can see that the CellStream Wireshark profile repository. We can go to the next one. Thank you. So like I was saying, we can go to the CellStream Wireshark profile repository, and they have a profile for anything you could think of. If you're working on VoIP, if you're working on IPv6, you're working on Quick, boom, they have. And he actually, they took one of my profiles that I built probably about 8 months ago. Kind of surprised at that. It's pretty interesting. But that's the QR code to get to that site. I promise it's not a malicious QR code. And something funny that I've thought about this whole time, the past 3 years I've been in this industry, is that they always tell us, don't scan QR codes, don't scan QR codes. But you go to every conference and every event, and there's QR codes everywhere. I just think that's kind of ironic, but it is really, it makes it very convenient. So instead of typing all that out, boom, you can boom. And yes, QR codes in this environment are perfectly safe. So, so again, why should we use a profile? It has your custom layout, your color rules, your display filters, and all that. And without profile, just you're re-adding columns or digging for fields that could be just set up as a button. And again, they're reproducible and shareable. You can instantly share it to GitHub. If you go to my GitHub at the end, you can see all the profiles that I've used in my Wireshark setup. So it's really perfect for teaching yourself what fields make a protocol so important. So I know Chris, he on his GitHub, he has a bunch of different profiles that you can export to your own Wireshark configuration. But we can go on to the next one. All right. This is just another look at my favorite columns and buttons. So this is my, as I was taking the Wireshark Certified Analyst course, this was the profile that I used the most. And there's some really cool filters here. There's some really cool buttons, and these columns just make it perfect to understand the whole flow of a TCP conversation. As you can see here, we have the payload length, which is just your payload in your TCP segment, and the sequence, relative sequence, and relative ACK number. So here, three-way handshake, SYN, SYNAC, ACK, got 0, 0, 0, 0. And so the ACK number is, sorry, we had some intrusion. It's okay. Here, you can see the SYN, SYNAC, ACK, all three for that one handshake. And then down here, we get to HTTP. If you look at the buttons on top, you can see that there's two separate streams, two separate streams. So TCP streams. So if I click on, say, packet 3, and I click the TCP button, it will just show me, like, right click, and you just follow that TCP stream. But you won't have that little pop-up. That won't be there. And then here, the buttons on the side is decreasing and increasing your stream. So if I'm on stream 1, it'll just show me that entire TCP conversation for stream 1. And I can click back and it'll go to my very first, or 0 because it's indexed. It will show me that stream. And again, I won't have to right click and go down to TCP stream and follow. It's right there. And the way that filter is set up, if you look at it here in red, the TCP.stream equals TCP.stream, that's saying I want to go to the TCP stream I am in right now. And then next it to the left and the right, all I did was +1 to go back a TCP stream, and then -1 to go, +1 to go up 1, -1 to go down 1. So it's real interesting that you can do math inside of these filter buttons. The one I use a lot, TCP.delta time is greater than 2 or greater than 5, and that would just show me all of the slow packets. So we can go on to the next one. So here are 2 different profiles, just a little more granular so you can see the differences that are available. At the top is your default. That's the one that Wireshark comes with it, and it just opens up as is. So you can see a lot of stuff from our previous slides is missing here. It has the source and has the destination, but it doesn't have the source ports, delta time, payload, sequence number, ACK number. It doesn't have all that. And that's fine. But this is where we can just start build upon what we know. Okay. The second one is that WLAN security again. It shows you the sequence numbers, the SSID, the specific protocol, 802.11, length, info, and again, has all those buttons at the top. So, and one cool thing here, if you look right underneath the filter bar, it shows you the density of the conversation as it goes over time. And I haven't delved into that much, but that's something to look at. I don't know exactly what it's called, but I think that's a really cool feature of the wireless profile. And again, you can import other people's profiles and start where they left off. So we can move on to the next one, please. Here we go. I'll get a little bit deeper on this one. This is the TCP 3-way handshake. And I didn't understand it until I started using Wireshark, and I really break it down for me. Okay. The SYN-ACK, ACK. You got your client saying hey to the server. The server says hey back, and then you acknowledge that hey. So the initial sequence numbers to use for outgoing data should not be predictable. That's why we use relative sequence numbers instead of raw. Or that's why they use random raw sequence numbers, because those are huge. They are very huge numbers. Like you see in this first one, the raw sequence number is a very large digits, very large. And it's easier for us to keep track of these smaller relative. And there's certain things that are known in the handshake that nowhere else in the entire capture other than in the handshake. That'll be your window size, which is the buffer space that you have for incoming or outgoing traffic. And at some point, I think in the 90s, we didn't change that specific window size value, but as our information started getting larger in data, we had to add in an RFC 1323 for the ability to negotiate a larger window size. This is done with window scaling, and it can only be done in power of 2. So with so initially each window size is 65 535, and now we can go up to even more. We move on to the maximum segment size, which is the MSS. It's one of the TCP options. It's just the largest segment the local host will accept. And the MSS is linked to the MTU minus 40 bytes of the TCP and IP headers. So one of those main values you'll see for the MSS is 1460. Anything lower than that, there's overhead. There's stuff in front of that TCP and IP headers. It's usually like a VPN or some other type of connection. So, but what's cool about the three-way handshake is that a lot of this, the way it's written, like the RFC is written, the programmer can implement it in a bunch of different ways. So there's a lot of uniqueness to each handshake, and that's what we're going to get into later. He's talking about JA4 and JA4 Plus. It uses all those specific values to differentiate applications, differentiate just operating system values and whatnot. Close the door, please. Close the door. Please close. Thank you, baby. All right, guys. Sorry about that. Let's keep going. Let's go to the next slide, please. All right. So like I was saying, every operating system, every application, every library, I know. I think he just wanted one of his games or something, but it'll be okay. Like I said, every operating system, every application, every library, every developer implements TCP handshake differently while staying within the bounds of the RFC. And this helps us fingerprint clients, or servers, or applications, and we'll look at that soon. So here I was just going over looking at relative sequence and relative ACK numbers, and this is still something that I have trouble with on the math side. As you can see here, the payload length is added to the relative sequence number is actually the next ACK. So if you look here, the payload of the fourth packet that's pretty much highlighted is 1460. So we take the sequence number, we add that payload length, and we have 1461. And we keep doing that until we get down here to this HTTP packet. And that's just a reassembled, so you can see all the information for that post. Let's see. A lot of this information we don't see if we're doing endpoint detection and response, or if we have managed detection or XDR. And our SIM is logging a lot of these connections, but it's not seeing that metadata, or some may not, but this is why it's important to have that that depth, that defense in depth. So if you have one security tool you're using and that goes down, kind of SOL. But to have a backup, or maybe it's not your main tool you use, but if you got something stacked away and it's backed up and you're capturing these packets, maybe using Zeek or something, and just recording everything on the wire, and that really helps. There's a lot of the tools that we have, the CrowdStrike and whatnot, Haven't used it, so I can't say with experience. But like I said, some of that stuff you just don't see. And having that record of every single connection, every single packet that went through your network is a gold mine of data if you need to go back. Okay. We could move on to the next one. I may have to start speeding up a little bit. So, um, at some point, I heard someone say encryption made network monitoring obsolete. You know, before we had wide use of encryption, you can see a lot of the data in those packets. You can see everything pretty much. But now, in the past, what, 15 years, 10, 15 years, most of the connections you'll see today, most of the connections you'll see today are encrypted. And so the only information we can glean out of, and now we're getting to a point where you can't anymore, is your server. Wow, brain fart. You'll see in the next few slides what information you can see and what you can't. But so our XDR, MDR agents, all of our telemetry and our log ingestions, they share one structural weakness. They depend on something, on the host or an app choosing what to report. Like I said, what we're doing here with Wireshark, say Zeek or Suricata, this is out of band management, out of band detection, you know. And I'm not those EDRs, MDRs, XDRs, those are great to have. They are great, but again, you can't just have one thing. You know, and that choice of reporting what to see and what not is kind of a potential flaw in endpoint and log-based detection. And I see a lot of companies are doing better at more defense in depth. Build your posture, get these NIST and CIS protocols, this framing, this framework, and map it. And just looking at what they suggest you do. And I know there's a lot of companies that have to based on compliance and regulation. And even if you're in an environment where you don't rely on these frameworks to, make sure you're in compliance. It's still a great idea to look through these sys controls and NIST and figure out what can help me in my environment. Okay. And I was just watching one of Eric Conrad. I just learned about him in the past, I think, 3 weeks. And I've been eating up his stuff online. Just he really helped me to add some more information in this presentation. And he was quoting a former NSA tailored access operation lead. He said, nation state red team's biggest fear is an out of band tap. Zeek and Suricata sitting passively on a span port, usually your last hop before the internet. Or mine at my house, I have it on the span port. It's my trunk ports, and then it's mirrored to a span port that's feeding into my Zeek. And that was really fun setting up. So if you haven't done that lately, this could be done on a Raspberry Pi, an old laptop. You throw on Ubuntu. I mean, I got like 10 laptops out here that just are running headless for all my different applications. And I know they're going to burn up soon and just break, but it's my home lab. So, like I was saying, with defense in depth, each layer of our defense should fail separately. So we're not SOL. We still have some visibility of what's happening. But there, we could move on to the next one, please. Okay. What can we see on the wire that our EDR and our XDR cannot? Network cat, it's not necessarily better than the EDR, like I was saying before, but it's independent of it. So it's always a backup. It just helps to have that backup. And everything we've covered so far about Wireshark has led us to here. And It's these small and insignificant details and variables inside our handshake or any of those Wireshark data, values or metadata that are crossing the wire. They speak volumes. They can tell us a lot of information. And like I was saying about my own home lab, Jaffor and Zeke fed from my span port, I can see there's in this next slide or next to it, it'll show you exactly what I'm talking about. And with all of these Jaffor plus fingerprints, it originates from the network data. And the net code, like the libraries that build the TCP code and the HTTP or the TLS libraries, this is what we're using to uniquely identify clients and servers. And Jaffor Plus is not a magic bullet by any means, but the fingerprints can be used to pivot. Say you have an incident response and you need to figure out, hey, are there any other, malicious actors on my network? And using these fingerprints, it regardless of IP address, MAC address, whatever, they'll pop out like a sore thumb. It's all based on their net code. They're the things they do to make the connection and whatnot. This is why it's really important to know your network. What are we using environment? What protocols are we using? Where's our traffic going? Where exactly is it coming from? What is our risk? What cipher suites do we use? And that'll you'll see in a slide or two that's important. That's really important. What are we doing to protect ourselves? Is there any network documentation? That's the first thing I do is I document my network. I know exactly what's on it and what it's doing and where it's going. And I know I don't have a very big network, and I know a lot of this is going to be probably hard for larger companies, but we can move on. I think I got to talk a little quicker. All right, Jaffor Plus is made by John Athouse, John Atkinson, Jeff Atkinson, and Joshua Alexander. It used to be a Salesforce, JA3, JARM, and Jaffor Plus. Now it builds upon what JA3 and JARM were doing, TLS fingerprinting. What's cool about these, Jaffor, is it's human readable and machine readable, perfect for JSON. And as you see the fingerprints you go by, just like with our coloring rules for Wireshark, you can see what's in the packet without looking at it. And it's like, again, regardless IP rotation, what they're doing. Malware detection, compliance, automation. Go on to the next one. Yeah, I'm going to wrap this up here in a few minutes for you. I'll 5 minutes, I guess. Jaffor Plus. These are all the different fingerprints in the suite. So you can do the TLS, HTTP, client server. Oh, the latency one's kind of cool, is you can kind of map where they are. Certificate fingerprinting, SSH fingerprinting, TCP, TCP server response, and all these different things. And these are all available in Wireshark. Well, the first TLS client fingerprinting and server response are default available in Wireshark, and everything else you need to have a plugin. Go on to the next one. We'll look at these and then we can call it quits, and I'd be happy to do a part two next time if y'all are interested. So real quick, we just look at these handprints and we can get it going. So for this TLS fingerprint, client hello and TLS server hello. The server hello is directly dependent on the client. So if your client changes, the server, if it's the same server, it's going to be a different response because some of these values are based on the client fingerprint. But here, if you look for the client fingerprint, T is either it's protocol, like what protocol is here, TCP or QUIC. And the TLS version is 1.3 in this. If it was 1.2, it would be 1.2.1.1 or 1.10. Next one is if it's going to a domain or if it's just going to an IP address. A lot of our malicious traffic is going straight to an IP address. There won't be a SNI. Next one is the number of cipher suites, and then the number of extensions. And then that last value, H2, is the first ALPN value. That's the application layer protocol. There's 3 pieces, A, B, and C. B is the truncated 256 hash of the cipher suite sorted, and then the extensions are sorted as well as they in the order they appear. And the TLS server response, so we're still using TCP. The server responded with 1.2, TLS 1.2, with the number of extensions, ALP, again, the cipher suite chosen, and the hash of the extension in the order they appear. For here, this is what's really cool. If you have a relatively static environment and you want to know, or whether it's static or not, you want to know what are my servers, what kind of cipher suites are they using? Are we within compliance and whatnot? You just take a quick JAW4S fingerprint of what your traffic coming out, and boom, just from JAW4SB, that could tell you exactly what you got coming out, or if you are in compliance. So, like I said, the TLS hello packet is unique per application or its underlying TLS library. So, but I can, based on time, I think I'm going to have to wrap that up. I'll make sure to post a video or get another blog going. So if y'all are interested, you can pick it up there. Sorry, I couldn't get done quick enough.
That it's a lot, Peter.
It is.
Taught Wireshark before. You are not. It is not a you thing.
I know.
I've been there. So it's a lot to cover.
It is.
I've broken up what you went over in 45 minutes into like 5 days of content, 5 8-hour days of content with labs. So that was a lot, and I know that there's more. That's amazing.
A lot more.
I've got some ideas.
Thank
I will
you.
follow up with you and Rihanna.
Please do.
And see if maybe there's a Peter course on Wireshark that could go through Cyberspeak Labs. So
I'd be happy to do whatever y'all need.
I think you do great.
Love to. Thank you.
That was amazing.
Thank you.
Like I said, I've taught Wireshark before, and I learned things.
Good.
So
that was
cool.
my hope. I was hoping for that.
Thank you so much. There are a lot of great comments in the chat. You've blown away our audience.
Thank
Peter,
you.
thank you so much.
Thank you.
And I'm going to transition to our next speaker, and I will see you.
I appreciate all of you. Thank you so much for letting me come on.